Hey everyone, this is Ashwin Nayaka from Civil Department, pursuing degree from Sri Venkateswara College of Engineering. I'm here to give a brief explanation on our final year project about smart agriculture system. These are my fellow mates Bharat Kumar from ECE Department, Ambrish and Arud from CS Department. Under the guidance of Dr. Pratima VR, CSC AI Department, Professor Swapna CH from ECE Department and Dr. Lata MS from Civil Engineering Department. Coming to introduction, in modern globalization, many technologies are trying to update a new development based on automation which works very rigidly, high efficiently, and within short period time. Now, the approach of this project is to develop smart machine which do right thing in the right place at the right time with the right amount and process of farming. There are different processes in farming system like plugging, cultivating, weeding, harvesting, etc. All these processes are advanced by modifying the mechanism in farming, which works automatically without manpower requirement. So which will reduce the manpower and give a efficient crop growth for a farmer. So the main objective of this project is to sustainably increase the agriculture productivity by remotely monitoring the crop growth and the quality of soil, to monitor the temperature, moisture, and humidity content in the surrounding environment and analyze the data, to automate the process of irrigation and fertilization to the plant. So this is our build wireframe of our model. With the help of start button, the soil moisture sensor, humidity sensor, temperature sensor, and peak sensors will be running, which will be directly connected to the Node MCU, which is directly connected to the Wi-Fi module, where the Wi-Fi module will display notification sensor reading to the monitor. And again, the Node MCU will be connected to the fertilizer tank, NPK sensor, and moisture sensor, where moisture sensor will be sensing the soil moisture value, and depending upon the soil moisture value, the water pump will be running. And depending upon the fertilizer sensor, humid sensor, the NPK value, NPK sensor, the fertilizer tank will run. From the required threshold, which will be given, the motor will pump the fertilizers and the water as per requirement. And if the stop button is pressed, the system will stop. Again, this is our block diagram of a model. Uh, there will be a power node MCU where the soil moisture, NPK sensor, THT sensor, and heater and fan to control the temperature. And this relay will be connected to the water and fertilizer pump. Depending upon the NPK sensor, as per given threshold, the fertilizer will pump the fertilizer tank will pump the fertilizer. And depending upon the moisture and moisture value of the moisture level of the soil is less, the water will be pumped. And if the soil's moisture level is as per requirement, the pump will be at off. And all this data will be sent to the Wi-Fi module in an IoT platform called Blink, and which can be in a web application and through the mobile phone. This is our implementation of a hardware unit, where you can see there is a NPK sensor and humidity sensor pump, and this is temperature controlling system. This is a software unit where all the coding is done of RS485 control pin, D3 and D4 pin is defined, and software series pins are also defined. And Wi-Fi name and password is also defined over here in a Blink platform, which is directly connected to a Blink platform. And relay and temperature is also set as per requirement. These are the data collected from a soil agriculture department from GKVK, where the crop name are listed. There are 23 crop name listed in a software where an individual has their own nitrogen, phosphorus, potassium value, which is nothing but NPK. Every individual crop has their own NPK value as per as like baby corn. It has 60% of nitrogen. It requires 60% of nitrogen, 30% of phosphorus, and 16% of potassium to grow. And coming to sunflower, it requires 36% of nitrogen, 36% of phosphorus, and 25% of potassium. As per wheat, it requires 40% of nitrogen, 30% of phosphorus, and 20% of potassium, and so on. This is our web application, web platform, where all the sensors value will be displayed. The NPK sensor value will be displayed here. As you can see, there's a potassium value as zero point 0.1, soil moisture value as 70, which means green. So it is as per requirement for required plant. You can select the plant, which plant you require, and temperature value and humidity value is also displayed. And these are the sensors and elements which we have used in our project. DHT11 sensor for temperature, submersive pump for pumping the water, relay, and testing.